Okay, right now we're going to do an assignment from Teach Teach Now. And it's going to be I do it, we do it, you do it together, and you do it alone. So it's I do it, we do it, you do it together, then you do it alone. All right, so first, I decided to do one of these problems from the review packet on conservation of energy. We remember that energy is conserved. So what we have here is the conservation of energy problem. And we are going to do this together. Well, I'm going to do the first part, we're going to do a part together, then you're going to do it alone. So what I'll do is, we know that kinetic energy, initial, plus potential energy, initial, is equal to kinetic energy, final, plus potential energy, final. Okay? So what we have here, hope you can see me, what we have here is a block. We have a block right here, sitting up here. This block is 1 kilogram. Mass is equal to 1 kilogram. And this block is going to travel this path. At this point right here, point B, is 10 meters up from the ground. At the beginning point of point A is 30 meters. And at point C right here is 25 meters. Okay, we can see that here. We know from our reading that potential energy equals mgh. So we're going to find the potential energy for point A, point B, and point C. So for point A, potential energy for point A is equal to mgh, always write that down. The mass is 1, the acceleration due to gravity is 9.8, and the height is 30. And that's going to equal 294 joules. We do the same thing for point B. P equals mgh. You got the mass is equal to 1. The acceleration to gravity is 9.8. The height is 10. And that equals 98 joules. And we do the same thing here for point C, and we'll do this one together. So potential energy is equal to mgh. The mass is 1 kilogram. The acceleration to gravity is 9.8, and the height is 25 meters, and that equals to 245 joules. We did it together. We got that one done. Now, each of the points we're asking to find the kinetic energy, the potential energy, and the total mechanical energy. So we found the potential energy. The kinetic energy is equal to 1/2 mv squared. We'll find that for each of the points, for point 1, point A, point B, and point C. So the kinetic energy of point A is going to be equal to we have 1/2, mass is 1, the velocity is 0. So the kinetic energy at point A is 0. And then we know that the mechanical energy equals the potential energy plus the kinetic energy. And here, ME is equal to PE plus KE, which is equal to 294 plus 0, which is equal to 294. And all this is measured in joules. Joules, 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 joules. I did it for point A, and I'll do it for point B, and we'll do it together for point C. This is supposed to be potential energy. Let's not get sloppy in our writing. Okay, so for point B, being that the object went down the slope down here at point B, the kinetic energy is equal to the initial potential energy, which is 294, minus the potential energy at that point, which is 98, which equals to 196 joules. And the mechanical energy is the same on all the 3 points. So here we have ME equal to 294 joules, and here we have ME equal to 294 joules. Right, kind of sloppy. So now that I did it, we'll do C together for the kinetic energy. Remember now, the kinetic energy at point C, after it travels all the way down here, is just going to be the kinetic energy at the beginning. I mean, the potential energy at the beginning, which is 294, and the potential energy at point C, which is 245. So we'll do this one together. So KE is equal to 294 minus 245, and that equals 49 joules. We'll do this together. So we got the potential energy here, potential energy here, potential energy here at the beginning. Then we got the kinetic energy on all 3 of the points. And then we have the mechanical energy right here for all 3 of the points here. We answered all the questions. So I did it, we did it, we and you did it together right here for point C. And now you do it alone with the next problem on your desk. Thank you very much.